Evan, and with me in my group are Callie, Connor, and Nathan. And we're going to show you the chemistry behind rock candy. Let's go!
Hey, I'm going to teach you how to make rock candy. First, you're going to get your trusty saucepan and pour in 2 cups of water. Once your water comes to a boil, you're going to add 4 cups of sugar. Once your sugar has completely melted, you're going to turn off the heat and pour your solution into a jar that you will cover with wax paper. Finally, you will attach a string into the jar for the crystals to attach to and wait a few days while your rock candy completes. In chemistry, we talk about solutions. In the case of rock candy, we're dealing with a supersaturated solution.
What's a supersaturated solution?
A supersaturated solution is a solution that contains more solute than solvent. Now you may ask, what are solutes and solvents? Solutes are the parts that are being dissolved in the solution, and solvents are the parts that are doing the dissolving. In the case of rock candy, sugar is the solute and water is the solvent. An example of a supersaturated solution is Kool-Aid. Kool-Aid is heated to high temperatures and some sugar collects at the bottom of the glass. This is showing that it's a supersaturated solution because there's more solute than solvent. Now, supersaturated solutions are unstable, causing the sugar to precipitate and cause the crystals in rock candy.
Oh, thanks, Connor.
You're welcome.
Oh, I have more questions, though. Callie, what happened?
It's Professor Callie. But what did happen? Check the syllabus.
Oh,
Did you become rock candy? What an anomaly. Let's see. Well, thinking about it, I think I might know why you turned into rock candy. Do you remember Professor Connor talking about supersaturated solutions?
Mm-hmm.
Okay, so as the temperature in your solution increased, the sugar molecules dissolved, and then once the solution cooled down, the crystals fell out of the solution as a precipitate, and you crystallized. But there's other reasons that you crystallized too. So Evan, another way to describe what happened to you is through Le Chatelier's principle. Remember learning about that in class?
Yes?
Okay, so you remember that Le Chatelier's principle states that when a system at equilibrium is pushed out of equilibrium, it'll try to regain equilibrium, right? So then when you think about it with what happened to you, as the temperature cooled, all the sugar crystals tried to generate more energy as they were losing energy, so they joined together and then the crystalline structure formed.
Thank you so much.
Yeah.
Why are these crystals in a repeating pattern?
Oh, that's actually a really good question. Good job, Evan. So it all comes down to the molecular structure of the water and the sugar that were in the solution as it precipitated. So everyone here knows the shape of water, right? Yeah. Alright, how about the shape of sucrose? It's a little bit different. But when you combine them, and then the sucrose, as it was precipitating, it forms in a repeating pattern, and then as it grows, it actually becomes visible on the rocks. That's how all crystals are formed too. It's pretty cool.
Thanks, Callie. How does sugar dissolve in water?
Well, sugar dissolves in water because of intermolecular forces. Intermolecular forces are weak forces that occur between discrete atoms and molecules. The 3 most common intermolecular forces are going to be London dispersion forces, hydrogen bonding, and dipole-dipole. Well, water is a polar molecule, and sugar is also made up of molecules that have polar areas. The polar ends of the water molecules are attracted to the oppositely charged polar ends of the sugar molecules. The sugar molecules and the water molecules are polar and have hydrogen bonds. Do you remember when we were learning about intermolecular forces that like dissolves like?
Yeah.
As the sugar was placed into water, hydrogen bonding occurred between the OH groups on both the sugar and the water molecules, which led to the sugar dissolving within the water.
Hey, baby, I'm just gonna shake, 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 shake. Shake it off, shake it off. Heartbreaker's gonna break, 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 break. And the baker's gonna bake, 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 bake. Baby, I'm just gonna shake, 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 shake. Shake it off, shake it off. I never miss a beat.
Now for our new discoveries. Scientists at the University of Bath have developed a new technique to detect glycade in the blood, and this will show them that there is early age dementia, Alzheimer's, and sometimes diabetes. The university has now gone and gathered scientists and biochemists and all of the walks of life that are the chemistry majors, and have developed this technique to go into the blood and the tissues in the human body to see what glycated proteins have been affected by sugars in the human body. This will then go into detail and to show what affects the body and what doesn't, and will hopefully help biochemists and people everywhere to find the cures for Alzheimer's, dementia, and some diabetes. Thank you guys so much for teaching me about rock candy and the chemistry behind it. Now I can go be a chemist too.